Good evening. Welcome to the first of two videos this evening on a very special coverage on the approaching major, potentially catastrophic storm for the Philadelphia and New York City metropolitan area, Sunday through Monday into Tuesday. And you could call this Hurricane Sandy, tropical storm, or subtropical storm, whatever you want to call it. It is a major, major weather event. So this first part of the video, I'm going to go over the current observations, what they mean for the storm, and what some of the terms are with this storm. The second video, I'm going to go into the actual forecast, break down the forecast once again for everyone, try to answer everybody's question. Should last about, both videos about 30 minutes. I'm going to shoot for about 15 minutes on this video and see what we could do with rocking this out. All right, so first of all, let's take a look at the winds currently as of 10 p.m. What are we seeing here? Well, we're already seeing winds exceeding tropical storm strength, at least in gusts, and sustained winds actually, at 49 miles per hour over North Carolina. Remember, the storm's all the way out here. And for a tropical system, that is a long, long ways away. And we're already starting to get reports of downed trees in portions of North Carolina. So what we're seeing here are winds are already starting to increase at a steady pace. The winds are coming in from the northeast. And by the way, for those of you in New York City, even though, Mr. Bloomberg doesn't think this is a major deal or a big deal to evacuate, leave. Leave now. Seriously. Get the heck out. Okay? This storm is going to be a serious storm. You can already see the winds are coming in from the northeast and basically starting to drive the water into the Long Island Sound, into the Battery. And this is going to be a long event. I'm not trying to scare you. I'm just telling you the facts. So here we are already on Saturday night. Winds from the northeast are already starting to pick up, already up to about 20 miles per hour over portions of the New Jersey coast. And we're just getting new data in right now. You can see the new data loading, and we're at 58 miles per hour gusts off of the North Carolina coast. This storm is not something to, not take seriously. Let's go look at the 850 millibar temperatures here. And the reason why I want to show this, I want to show you kind of the dynamic of the storm here. This is our hurricane. It's still a hurricane, by the way, just so you know. Now, our hurricane here is exhibiting some interesting, attributes, let's call them. For one, it's still tropical. Let's be clear about that. It has winds at 75 miles per hour. The pressure is down to 961 millibars. Why is this important? Because a pressure down to 961 millibars usually supports a Category 3 type hurricane. So why isn't this hurricane doing the same thing? The reason why is because it's not a pure warm core system. What I mean by that is this. When we look at a trough, let's say the trough that's over the northern plains, you can see temperatures getting colder as you move into the deeper portion of that trough or towards the upper level low. A warm core low pressure system like this one here, the temperatures get warmer as you move closer to the center of the storm. That's what's called a warm core low. Now I can go into all the details about what exactly is a hurricane and a warm core low and all that other stuff. But it would be a very long video, and some of you might actually get even more confused than what you are already. So I'm going to save that for now, maybe for a much longer post in the future. But basically, trust me here when I say that this is still a warm core low pressure system. What I want to point out here with this map at 850 millibars is notice the thermal gradient that's setting up here already. Very tight thermal gradient setting up with our cold front over the Ohio River Valley and portions of the Tennessee River Valley, going from 0 degrees Celsius to roughly 10 degrees Celsius over portions of western North Carolina. That's a 10-degree thermal gradient. And then you go off of the East Coast and you got temperatures around 20 degrees Celsius. That is very warm, and it is a very dynamic thermal gradient that is going to start to interact with this storm. That's one part of this storm that is going to, make for some very interesting weather. Keep that in mind in the second video. I think that's going to show up very important and a very important feature to keep an eye on as we move forward. So that's the 850 millibar. Now the 500 millibar. Why am I showing this? Because I want to show you that this storm is already being captured. Here's our trough. It's what we call a neutral position right now, starting to tilt towards the negative. And that's important because when it tilts towards the negative, this area of wind starts to support very strong divergence, separating of the winds. And when you separate the winds, you increase lifting. When you increase lifting, that's when you get a lot of precipitation. And you can see the trough is starting to catch our hurricane right now. It'll continue to try to move to the north-northeast. In fact, it's moving to the northeast as of 8 p.m., around 13 miles per hour. It's only about 330 miles to the south of Cape Hatteras, North Carolina. And it's moving steadily, but I think that's going to have to stop moving to the northeast. We should start to see more of a turn towards the north in the 11 p.m. Advisory as our hurricane starts to become trapped and slowly makes that turn towards the New Jersey coastline. That's right, I said New Jersey coastline. Take a look at the infrared satellite picture. This is interesting. We're going to be on this one for a bit. Excuse me. Got a little bit of cold too. Oh well. Okay, why is this important? Well, we have not seen a true complete transition to what's called an extratropical or non-tropical low pressure system. How do we know that? Because we still have thunderstorms, even in this late stage, developing right over the center of circulation. This is clearly still a warm core low, like I said, but why is this important? Because when you start getting thunderstorms developing around the hurricane or around the center, what you have is a release of latent heat energy. Think of it kind of like nitroglycerin to your gas tank, okay? You're throwing nitro into this gas tank, really firing up the storm and firing up the dynamics of this storm. So this additional heat content added into what's already a rather impressive thermal gradient, you end up with a lot of energy, a lot of lifting, and the potential for very intense thunderstorms and rainfall. And of course winds, very strong winds. So let's wrap this up here with the infrared satellite picture by basically letting me say this. This hurricane will remain a hurricane for about maybe another 24 hours before it becomes completely subtropical and then extratropical. And we'll know that because, well, when this storm goes extratropical, the pressure is going to drop another 10 millibars, somewhere between 952, maybe 950. And when it does that, believe me, you'll know it in the New York City and Philadelphia metropolitan area because these winds are going to get very powerful when that happens. Now, let me pull up the radar. Now, remember what I've been saying the past few days is I didn't buy the model guidance into thinking that the rain's going to hold off all day Sunday. I said that there's going to be a good potential of seeing some of this rain build into the northern mid-Atlantic, build into the New Jersey coast and the Philadelphia, New York City metropolitan area, with more scattered showers Sunday morning and then expanding in coverage. I did say that, right? Yep, I did say that. And the reason why is I didn't buy in some of this model guidance where it kept the dry air in place because you had such an increasing thermal gradient developing here. Well, we do have the increasing thermal gradient, and we have the easterly winds transporting moisture into the northern mid-Atlantic. And what are we starting to see? We're starting to see the atmosphere moisten up, and we're starting to see reports of showers off the New Jersey coast, extending down south through the Delmarva, down through North Carolina. Obviously, here's the start of our storm. And by the way, this storm expands all the way down to the Bahamas as far as rainfall. So, yeah, this storm's pretty big. The point here I'm trying to make is that look for these showers to continue to expand in coverage and become more widespread as we move through the day on Sunday. I think Sunday is going to be a little bit wetter than what people think. So if you're going to the Jets game, be prepared for some rainfall and potentially some gusty winds. They're already at around 10 to 20 miles per hour. Would not be surprised if they're around 15 to 30 at the start of the game and 20 to, let's say, 40 miles per hour by the time you're getting done with the game. Who knows? That could help the Jets throw the ball a little bit better. Who knows? But one thing it will do is make for some uncomfortable conditions at the Meadowlands with the Jets. So you can see the storm's already expanding in coverage, and you can see the rainfall already starting to try to push into the northern mid-Atlantic. Last but not least, it's my favorite tool. It's the satellite image that I grew up on. It is, of course, the water vapor satellite picture. This shows a very dynamic system. I'm not so much impressed with this. I mean, it's still very impressive. But the thing that really sticks out to me is this. This right here tells me a whole lot about the lifting mechanism of this storm and the strength of this storm. This storm, A, is expanding. B, it has a heck of a cutoff. C, all this dry air that you see right here, especially this, is indicative of very intense lifting here. Remember, what comes up must go down. Well, there's a lot of air going down here, and that means there's a lot of lifting going on over here. And this is all before, again, let me say this is all before the phasing of this disturbance right here with this storm. When this disturbance phases with this storm, you're going to see this low pressure system explode. Right now what we have is still a tropical low pressure system with some extratropical characteristics, specifically this right here and this right here. Okay? Once this phases with this, this becomes a very dynamic storm with a very strong 500 millibar low, but also it means that because of all this lifting air, the cold air from the stratosphere and the upper portion of the troposphere are going to crash towards the surface. Why? Because you have all this air rising over the ocean, and you have to have something to fill it in. Well, the air from the plains, or should I say the coastal plain, should I say, is not going to be able to fill this rising air as quickly as the storm would like. So what you end up with, in very, very general terms here, understand this is a very complicated process, but basically you have air from the troposphere, the highest portions of the troposphere, highest parts of the atmosphere, crashing down towards the surface. And that leads to very strong wind gusts in a dynamic storm. Now, some of you might have asked, well, what's the difference between this storm and a hurricane and a non-hurricane? Very complicated, but let me put it to you like this. A hurricane is a compact type storm. Very intense, but compact, small. A nor'easter is a very large event. What you have here in this event is a core that's very compact and very strong, transitioning to a very large storm. So within this very large storm, you have a very tight, compact secondary storm, let's say, a tropical storm. So what New Jersey is going to be dealing with, especially when this low pressure system slams into the central New Jersey coast, and what New York City is going to be dealing with, in Philadelphia and Delaware, is basically two storms in one. You're going to see the long duration type event from a nor'easter and a very dynamic and compact storm from a tropical system. Coming up next, we're going to talk about the forecast with this storm and break down the model guidance and a little chat with Mr. Bloomberg.